So in this video, we're going to check to see if Rolle's theorem or Raleigh's theorem can be applied to the function f of x equals x squared plus 2x minus 15 on the closed interval from -4 to 2. Okay? So if it can be, find a c in a b such that f prime of c is equal to 0. Okay? So we want to find a c in a b such that f prime of c is equal to 0. So some c between a and b. Now, first thing we got to do, Rolle's theorem. Remember, Rolle's theorem, we have to have f of x needs to be continuous on the closed interval and differentiable on the open interval. Well, what do we know about this function here? This is a quadratic, and a quadratic is a polynomial. So therefore, f is continuous because it's a polynomial on the closed interval, and it's also differentiable. It's smooth, right, on the open interval. Okay, so we don't have to prove that. We're just assuming if you tell me that it's a polynomial, then that's good enough. You just need to write out, hey, this is true. This follows because it's a polynomial. So since f is a polynomial, then the following is true, and that's good enough for me. Okay, this is Calculus 1. We don't want to go beyond the scope of the course. Now, if that's the case, then what I need to do next in Rolle's theorem, if you think about it for a second, Rolle's theorem says it's continuous on the closed, differentiable on the open, but then the next thing they do is they say that the endpoints are equal to each other. The y values are equal to each other at the endpoint. So I need to prove that that's true. So what are my endpoints? They're -4 and 2. So I'm going to take my function, and everywhere I see an x, what am I going to plug in here? I'm going to plug in a -4. And so when I do this, I have -4 squared is 16 times -4 times 2, which is -8, and then minus 15, that equals -7. Okay, and then I also need to plug in the other endpoint. So I plug in a 2 everywhere I see an x. If I plug in a 2 everywhere I see an x, I'm going to get 2 squared plus 2 times 2 minus 15, which is 8 minus 15, which is also -7. So what does this tell me? This tells me that the endpoint y values are equal to each other. That's another part of Rolle's theorem, right? I want to know that it's continuous and differentiable and that the endpoints are equal. Now that I know that I can apply Rolle's theorem, I'm going to do it. So Rolle's theorem says that there's some c such that the derivative evaluated at c is equal to 0. So what am I going to do? I'm going to take the derivative of f of x. So the derivative of f of x, well, the derivative of x squared is 2x. The derivative of 2x is 2. Derivative of -15 is 0. And then what do I do to the derivative? I set it equal to 0. Okay, so set it equal to 0. And then I need to find a value x that solves this equation here. So how do I do that? Well, I mean, I think we got this down. -2 minus 2, right? So I have 2x equals -2, so x is equal to -1, right? We got that? Okay, so x equal -1 solves this. So if x equals -1, f of -1, if I plug that in here, what do I get? I get 2 times -1 plus 2, which gets me 0. Okay, so this is a c value. You see that? This value here produces an output of 0 as desired. So what is a c between a and b? C equal to -1, which -1 is in this interval here, produces that. Okay, so that's what I'm looking for.